Hi guys, I am Angelika Nuñez and today I will discuss my topic about steel. This content is about what is steel, where steel came from, and later I will show you a video where people are making steel. In this video, you may know how steel made. I think it's exciting enough because it's not animated because the video is realistic. So watch, sit back and learn. So first, I will discuss about what is steel. Iron is made by removing oxygen and other impurities from iron ore. When iron is combined with carbon, recycled steel and small amounts of other elements, it becomes steel. Steel is an alloy of iron and carbon containing less than 2% carbon and 1% manganese, and small amount of silicon, phosphorus, sulfur, and oxygen. Steel is the world's most important engineering construction material. It is used in every aspect of our lives, in cars and construction products, refrigerators and washing machines, cargo ships, and surgical scalpels. It can be recycled over and over again without loss of property. Actually, steel is not a single product. There are more than 3,500 different grades of steel with many different physical, chemical, and environmental properties. Approximately 75% of modern steels have been developed in the past 20 years. If the Eiffel Tower were to be rebuilt today, the engineers would only need one-third of steel that was originally used. Modern cars are built with new steels that are stronger but up to 35% lighter than it in the past. Who invented steel? A British inventor, Henry Bessemer, is generally credited with the invention of the first technique to mass-produce steel in the mid-1850s. Steel is still produced using technology based on the Bessemer process of blowing air through molten pig iron to oxidize the materials and separate impurities. History of steel production. Steel is a discovery of the Iron Age, a period that started around 1200 BCE. Iron ore was first mined in Central Asia and Europe, and humans at this time used iron to make tools and weapons in a practice called ferrous metallurgy. Iron products evolved during this time, beginning with blacksmiths producing wrought iron goods. These trade pools learned to heat up iron ore, and using a hammer and anvil process, the blacksmith would remove impurities from the metal and produce a durable and malleable final iron product. Iron took a few other forms before eventually arriving at what is today considered steel. In China, Iron Age metallurgists heated up iron in large furnaces, effectively melting the substance into liquid and mixing it with the wood fuel. The melted liquid would then be poured into mold, which would then be left to harden, eventually taking the shape of cooking tools and other objects from the molds. This process, known as cast iron, produced a more durable product than wrought iron, but it was brittle, making it difficult to shape and bend. After cast iron, blacksmiths of Central Europe began coating wrought iron products in charcoal to improve the iron's strength while maintaining its flexibility. Afterward, iron went through a final iteration, which most resembles today's steel material. In India, iron workers developed an iron smelting process that combined the perfect ratio of iron to carbon, using crucibles or clay containers. The iron workers would blend iron and charcoal pieces together. While cooking, the iron would melt and absorb carbon atoms from the charcoal. After cooling down, the crucible contains what we know as steel, an iron-carbon alloy. After the discovery of iron-carbon alloys, various civilizations began to scale up their steel production practices, allowing them to make improved weapons, tools, and structures. Since the Iron Age, humans have looked to perfect the steel manufacturing process, not only to produce it in greater quantities but to produce it more effectively. The continuous improvement of steel production is the reason why steel today has become more crucial global commodity. The modern-day steel production process began in 1856 under a process known as Bessemer process. It's largely considered to be the first process used to mass produce steel. According to historians, two different inventors, one in the UK and one in Pittsburgh, both simultaneously developed a steel production process that involved removing iron impurities through the use of an air blaze. With this discovery, other steel producers began to perfect the process, eventually discovering a way to use the air blast technique to help preserve the carbon content while fully eliminating impurities. Finally, the process evolved to a highly cost-effective way of mass-producing high-quality steel that we use today. Today, steel is generally produced in one of two ways. Number one is blast furnace. The blast furnace process, also known as the basic oxygen process or BOP, combines raw iron ore with small amounts of steel, scrap metals into a furnace. Then, pure oxygen is blown into the furnace, raising its temperature. Not only does the scrap metal melt into a liquid at this temperature, but the iron impurities are also oxidized, evaporating completely. Additionally, the high temperature reduces the carbon content down to its steel ratio, resulting in liquid steel. Number 2. Electric arc furnace. In the electric arc furnace or EAF method, highly current electric arcs from electrodes melt large quantities of steel scrap into liquid. While the steel scrap metal is melting, the technicians add into a ferroalloys until the metal liquid reaches its desired ratio of steel to other alloys, such as chromium and nickel, which form stainless steel. To purify the steel, the furnace then blasts in oxygen, and lime and fluorspar are added. Then substances combine with the steel's impurities, turning into slag. The slag then flows to the top of the molten steel where it is removed, leaving behind the pure steel. The EAF method is the most common steel production method today. Today's modern EAF steel-making furnace produce 150 tons of steel per melt, which take approximately 90 minutes. For over 25 years, Summit Steel has been helping businesses efficiently produce parts through cutting-edge production and manufacturing processes. Our contract metal manufacturing services range from initial design and engineering support to laser cutting, 3D machining, and steel and metal welding processes. Our flexible service offering can be tailored to meet whatever volume of production your business needs. From single-source capabilities to high-volume orders, Summit Steel can deliver the high qualities, precision manufactured metal and steel products and part of in their industry. Metal manufacturing and design brings together a range of experts from designers, engineers, and consultants to welders, metal workers, and installers. Every expert has a role to play in ensuring the steel and metal materials get turned in well-designed, high-quality components and end products that go on to serve an important role in our global marketing. Steel is a versatile, affordable, and abundant material, making it the perfect substance to use in countless manufacturing capacities. Originally, equipment manufacturers and other fabrication companies rely on the value of steel to produce their original components and products. Steel production. In the steel production, following stages are identified: production of pig iron, production of liquid steel, hot rolling and cold rolling, applying a metallic and or organic coating. There are two main processes for producing steel: by means of a blast furnace or equal to indirect reduction, in combination with a converter or by means of an electric furnace. In the form process, iron ore is the main raw material. In an electric furnace, scrap iron is used and occasionally also sponge iron. Sponge iron is an intermediate product which is produced by iron ore by means of direct reduction or equal to DRI or direct reduced iron, and then further reduced and smelted in the electric furnace. Steel is a discovery of Iron Age, a period that started around 1200 BCE. Iron ore was first mined in Central Asia and Europe, and humans at this. What is Bessemer process? The Bessemer process was the first inexpensive industrial process for the mass production of steel from molten pig iron prior to the open-heart furnace. The key principle is the removal of impurities from the iron by oxygenation by blowing air through the molten iron. The oxidation raises the temperature of the iron mass and keeps it molten. Such process using air to purify iron had been used outside of Europe for 100 years, but not on industrial scale. The process had existed since the 11th century in Asia. The modern process is named after its inventor, Henry Bessemer, who took out a patent on the process in 1956. The process allowed for such projects of industrial scale, including creation of railroad lines. One of the first Bessemer steelmaker operations appeared in near Stilton, PA in 1985. Can be steel recycled? Yes, very easily. Steel's unique magnetic properties make it an easy material to recover from the waste stream to be recycled. The properties of steel remain unchanged no matter how many times the steel is recycled. The electric arc furnace or EAF method of steel production can use exclusively recycled steel. The blast furnace basic oxygen furnace route can use up to 30% recycled steel. So here are the artifacts of steel. Did you know that when iron combined with carbon, recycled steel, and small amounts of other elements, it is transformed into a much stronger material called steel? Used in a huge range of human-made applications, steel can be 1,000 times stronger than iron. Did you know that all steel is originally made from iron? Iron is the fourth most common element in the Earth's crust after oxygen, 46%, silicon, 28%, and aluminum, 8%. When liquid iron is converted into steel, it reaches temperature of up to 1,700 degrees Celsius, significantly hotter than volcano lava. Wow, amazing! Did you know that 3rd century BC, craftsmen in southern India were used crucibles to melt wrought iron with charcoal to produce Wootz steel, a material that is still admired today for its quality? Did you know that in blast furnace or integrated route to produce 1,000 kg of crude steel that mainly involves a rolly, 1,370 kg of iron ore, 780 kg of coal, 270 kg of limestone, and 125 kg of steel scrap. Wherein electric arc furnace route, the primary raw material is steel scrap, direct reduced in iron and or hot metal and electricity to produce 1,000 kg of crude steel, and EAF routes use rolly, 710 kg of steel scrap, 586 kg of iron ore, 150 kg of coal, and 88 kg of limestone, and 2.3 GJ of electricity. Also, did you know that a basic oxygen furnace can be charged with as much as 30% scrap? Most steel products remain in use for decades before they can be recycled. Therefore, there is not enough recycled steel available to meet growing steel demand. Did you know that an electric arc furnace can be charged with 100% steel scrap? Did you know that steel closes the material loop without being confined to a single application? All types of steel can be recycled back into new steel of various grades, keeping their inherent material properties. Did you know that steel is permanent material that can be infinitely recycled and is 100% recyclable without loss of quantity? Last, did you know that the industry is working together on many initiatives to develop breakthrough steel-making technologies that could reduce carbon O2 emissions by more than 50%, potentially revolutionizing the ways. Have you learned something from the video? Even though I'm shattering, just joking. Hope you learned something from my video and my explanation. And if you like the video, please press like. And so the discussion is over. So bye.